factor. And today we're going into an awesome adventure. Who loves adventures? Great! And I'm sure you will love it even more because our adventure for today involves one of the basic concepts of calculus, derivatives. Who loves calculus? Yes, so I guess you are both ready. Very ready. So sit back and relax as we bring you to the journey to find the hidden treasure using the derivatives formula in its application.
Hi, I'm Amor. Good job! Welcome at the Station 1. For you to proceed at the next station, you must first learn the definition of derivative. The definition of derivative is... Here are the 3 examples.
Given number 1, f of x is equals to 2x squared minus 16x plus 35. So, all we really need to do is to plug this function into the definition of the derivative. First, plug the function into the definition of the derivative, which is f prime of x is equals to limit of f times x plus h minus f of x all over h as h approaches to 0. Substitute the x from the given formula, and it becomes f prime of x is equals to limit of 2 times x plus h squared minus 16 times x plus h plus 35 minus the given of f of x, which is 2x squared minus 16x plus 35 all over h as h approaches to 0. So, we are going to have to do some work. In this case, that means multiplying everything out and distributing the minus sign through on the second term. First, expand the 2 times the quantity of x plus h squared, and it becomes limit of 2x squared plus 4xh plus 2h squared. Then, substitute the negative 16 from the x of x plus h, and it becomes negative 16x minus 16h. Then copy plus 35. Then minus 2x squared plus 16x minus 35 all over h as h approaches to 0. Cancel like terms with different signs, which is the 2x squared, 16x, and 35. The remaining are limit of fxh plus 2x squared minus 16h all over h as h approaches to 0. Notice that every term in the numerator didn't have an h in it. Cancel out, and we can now factor an h out of the numerator, which will cancel against the h in the denominator. After that, we can compute the limit, which is the limit of h times 4x plus 2h minus 16 all over h as h approaches to 0. Cancel out h, then it becomes limit of fx plus 2h minus 16 as h approaches to 0. So we all know that h approaches to 0, so distribute the h to 0, and it becomes 4x plus 2 times 0 minus 16, and the answer is f prime of x is equals to 4x minus 16. Second given, g of t is equals to t over t plus 1. The outside of this will work in exactly the same manner as the previous examples. First, we plug the function into the definition of the derivative, which is g prime of t equals the limit of g times t plus h minus g of t all over h as h approaches to 0. Note that we change all the letters in the definition to match up with the given function. Also note that we wrote the fraction a much more compact manner to help us with the work, which is limit of 1 over h times t plus h over t plus h plus 1 minus t over t plus 1. Then, cross-multiply the given function. It becomes limit of 1 over h times t plus h times t plus 1 minus t times t plus h plus 1 all over quantity of t plus h plus 1 times the quantity of t plus 1 as h approaches to 0. Next, as with the first example, after the simplification, we only have with the h in the left in the numerator, so we can now cancel an h out. So, upon calling to h, we can evaluate the limit of the derivative, which is the limit of 1 over t plus quantity of t plus h plus 1 times t plus 1 as h approaches to 0. Since h approaches to 0, substitute the h with 0. It becomes 1 over the quantity of t plus 1 times the quantity of t plus 1. Since they're both alike, you just given number 3. R of z equals square root of 5z minus 8. First, plug into the definition of the derivative as we've done with the previous two examples. R prime of z is equals to limit of r times z plus h minus r times z all over h as h approaches to 0 equals limit of square root of 5 times z plus h minus 8 minus square root of 5z minus 8 all over h as h approaches to 0. In this problem, we're going to have to rationalize the numerator. We multiply both the numerator and the denominator by the numerator, except we change the sign between the two terms. Becomes limit of quantity of square root of 5 times z plus h minus 8 minus square root of 5z plus 8 all over h times quantity of square root of 5 times z plus h minus 8 plus quantity of 5z minus 8 all over the quantity of square root of 5 times z plus h minus 8 plus square root of 5z minus 8 as h approaches 0. Multiply both the numerator and it becomes limit of 5z plus 5h minus 8 minus 5z minus 8 all over the multiplied quantity of the denominator, which is h times square root of 5 times z plus h minus 8 plus square root of 5z minus 8. Cancel out h and it becomes limit of 5. Cancel out like terms with different signs, like 5z, 8, 5z and 8. And the remaining is the limit of 5h all over h times the quantity of square root of 5 times z plus h minus 8 plus quantity of 5z minus 8 as h approaches to 0. Cancel out h equals limit of 5 all over square root of 5 times z plus h minus 8 plus z 5z minus 8 as h approaches to 0. Change h to 0, it becomes 5 all over square root of 5z minus 8 plus square root of 5z minus 8 equals to, and the answer is r prime of z equals 5 all over 2 square root of 5z minus 8.
Constant times function. If c is a constant, then quantity c of x is equals to c d over dx f of x.
Given number 1, f of x equals 2x squared. First, we need to find the derivative of 2x squared. So, f prime of x equals 2d over dx x squared. And then, we times the constant and function. So, the constant here is 2 and the function is squared. So, f prime of x equals 2 times 2 x squared minus 1. So, the final answer is f prime of x equals 4x. Given number 2, f of x equals 3x raised to the power of 4. So, the same in given number 1. So, we need to find the derivative of 3x raised to the power of 2. So, f prime of x equals 3d over dx x raised to the power of 2. And the constant is 3 and the function is 4. So, f prime of x equals 3 times 4 x raised to the power of 4 minus 1. So, the final answer is f prime of x equals 12x cubed. Given number 3, f of x equals 7x raised to the power of 4. So, the same in given number 1 and given number 2. So, we need to find the derivative of 7x raised to the power of 4. So, f prime of x equals 7d over dx x raised to the power of 4. So, the constant here is 7 and the function is 4. So, constant times function. So, f prime of x equals 7 times 4 x raised to the power of 4 minus 1. So, the final answer is f prime of x equals 28x cubed.
Sum and difference. The derivative of a sum or difference is equal to the sum or difference of the derivatives. Together with the power rule and constant rule and multiple rule, these rules allow to differentiate and any polynomial.
The first example of sum and difference rule is f of x equals 7x raised to the power of 5 plus 3x squared minus 4x plus 12. And now, we're gonna distribute in the derivative of each term. So, d over dx 7x raised to the power of 5 plus d over dx 3x squared minus d over dx 4x plus d over dx 12. So, the next step is take the derivative of each term. So, the derivative of 7x raised to the power of 5 is 7 times 5x raised to the power of 5 minus 1. And the derivative of 3x squared is 3 times 2x raised to the power of 2 minus 1. And 4x is, the derivative is minus 4 times 1. The final answer is f prime of x equals 35x raised to the power of 4 plus 6x minus 4. So let's proceed to the second example. P of x equals negative x raised to the power of 4 over 2 plus 3x cubed minus 2x. So now we distribute the derivative of each term. D over dx negative x raised to the power of 4 over 2 plus d over dx 3x cubed minus d over dx 2x. And now we pulled out the negative 1/2 because the x is equal to 1. And now we get the power rule of x raised to the power of 4. So 4x raised to the power of 4 minus 1 plus the derivative of 3x cubed is 3 times 3x raised to the power of 3 minus 1. And the derivative of 2x is equal to 2 times 1. For the next step, we multiply the negative 1/2 and the 4x cubed and plus 3 times 3x squared minus 2. And the final answer is g prime of x is equal to negative 2x cubed plus 9x squared minus 2. So now, let's proceed to the last example, which is the y of x equals 1 over x raised to the power of 5 minus 2 over square root of x plus 2. So now, we rewrite it into a polynomial form, which is x raised to the power of negative 5 minus 2x raised to the power of negative 1/2 plus 2. And the next is we distribute the derivative of each term. Y prime of x equals d over dx x raised to the power of negative 5 minus d over dx 2x raised to the power of negative 1/2 plus d over dx 2. So now we will get the constant multiple. So in an x raised to the power of negative 5, the derivative is negative 5x raised to the power of negative 5 minus 1. And the derivative of 2x raised to the power of negative 1/2 is 2x raised to the power of negative 1/2 minus 1 plus 0. So next is to use the constants times function. Y prime of x equals negative 5x raised to the power of negative 6 minus 2 times negative 1/2 x raised to the power of 3 over 2, because negative 1/2 minus 1 is equal to 3 over 2. So the final answer is y prime of x equals negative 5 over x raised to the power of 6 plus 1 over x raised to the power of 3 over 2. So that's how we take the derivative of sum and differences.
Hi, I am Garbo. You must know the fifth rule, which is the product rule. The product rule is a formal rule for differentiation problem where one function is multiplied by another. The rule follows from the limit definition of derivatives and is given by, remember, the rule following way each time differentiate and differentiate in the product and add two terms together.
We will figure out the derivative of f of x is equal to 2x times 5x squared plus 3x. The formula of product rule is UDV plus VDU. Then, grab our two functions. The 2x is our first function, and 5x squared plus 3x is our second function. Let's say our first function is u and our second function is v. Finding the derivative individually, the derivative of u is 2. And then the derivative of our second function is 10x plus t. Now we have the both of their derivatives. We will put things together. So f prime of x is, first write down the first function, which is 2x, multiply by the derivative of our second function, which is 10x plus 3, then add the second function, which is 5x squared plus 3x, then multiply by the derivative of our first function, which is 2. Then distribute 2 to 10x, so 2 times 10x is equal to 20x squared. 2x times 3 is equal to 6x. Then distribute the other side. 2 times 5x squared is equal to 10x squared. 2 times 3x is equal to 6x. Then combine things. 10x squared plus 20x squared is equal to 30x squared. 6x plus 6x is equal to 12x. So, let's say the derivative of 2x times 5x squared plus 3x is f prime of x is equal to 30x squared plus 12x. We will figure out our second example of derivative, which is y is equal to quantity of 5x squared. First, we will factor out 5x squared, so 5x times 5x. Then use the formula of product rule, which is UDB plus VDU. Our first function is 5x. Let's say this is u. And our second function is 5x. Then let's say this is v. So u is equal to 5x. Then the derivative of u is equal to 5. Our v, second function, is equal to 5x. The derivative of v, which is 5x, is equal to 5. Then, let's put things together. So, u dv, so u is 5x. Then, the derivative of v is 5. Plus, the second function, which is v, is equal to 5x. And times the derivative of u, which is 5. Then distribute 5 times 5x is equal to 25x. Plus 5x times 5 is equal to 25x. So let's say the derivative of quantity of 5x squared is y prime equals 50x. We will figure out our third example. So h of x is equal to 4e dx times square root of x. Then use the formula of product rule, which is udb plus vdu. Our first function is 4e dx. Let's say that is u, and square root of x, that is v. So our first function is 4e dx, and the derivative of 4e dx is 4e dx. Then our second function v is equal to square root of x. The derivative of square root of x is 1 over 2 square root of x, because we take the derivative of x, derivative of d over dx times x raised to the power of 1/2. Then we will use the power rule. So 1/2 x raised to the power of negative 1/2, and we can write this as 1 over 2 square root of x. Now we have the both of their derivatives. We will put things together. So h prime of x is equal to 480x, which is our u, times derivative of v, which is 1 over 2 square root of x, plus v, which is square root of x, times the derivative of u, which is 480x. So, let's multiply 480x times 1 over 2 square root of x is equal to 480x over 2 square root of x, plus square root of x times 480x is square root of x times 480x. So we can cancel 4 and 2 because it is divisible by 2, and 4 becomes 2 and 2 becomes 1, plus square root of x times 480x. So let's say the derivative of f of x is equal to 480x times square root of x is equal to h prime of x is equal to 280x over square root of x plus square root of x times 4e to the x.
The quotient rule states that the derivative of f of x is equal to f prime of x is equal to g times the derivative of x minus f times the derivative of g over g squared.
So, we're gonna find the derivative of x over 2x minus 4. First, know the value of f. And our f here is x. And our f prime is 1. Also, the value of g, which is 2x minus 4, and our g prime is 2. Next, substitute. F prime of x is equal to 2x minus 4 times the derivative of x, which is 1, minus x times the derivative of 2x minus 4, which is 2, over 2x minus 4 squared. Next, distribute. 2x times 1 is equal to 2x. Negative 4 times 1 is equal to negative 4. Minus x times 2 is equal to x over 2x minus 4 squared. After that, cancel positive 2 and negative 2. So here it goes, negative 4 over 2x minus 4 squared, and that's the final answer. So how about this given? 7x plus 4 over x squared plus 5. Using the formula, f prime of x is equal to x squared plus 5 times the derivative of 7x plus 4, which is 7, minus 7x plus 4 times the derivative of x squared plus 5, which is 2x over x squared plus 5 squared. Next, distribute. X squared times 7 is equal to 7x squared plus 5 times 7 is equal to 35, minus 7x times 2x is equal to 14x squared, minus 4 times 2x is equal to 8x, x over x squared plus 5 squared. Next, arrange. 7x squared minus 8x plus 35 over x squared plus 5 squared, and that's the final answer. Next is quotient rule with radical. And our third given is square root of 15 over 48. We're gonna rewrite this as square root of 15 over square root of 48. 48 factored by 16 times 3, so we're gonna factor 48. Square root of 15 over square root of 16 times square root of 3 is equal to square root of 15 over square root of 16, which is 4 times square root of 3. But that is not the final answer. We're gonna factor also 15. So square root of 5 times 3 over 4 times square root of 3. Next, we're gonna cancel square root of 3. Is equal to square root of 5 over 4. And that's the final answer.
5 minutes later.
You must learn the higher order derivatives concept, and here's how you solve it.
Find the second derivative of f of x equals 3x raised to the power of 5 plus 2x cubed plus 6x plus 4. Now let's derive. F prime of x equals 3 quantity of 5x raised to the power of 4 plus 2 quantity of 3x squared minus 6 times 1 plus 0. Next, f prime of x equals 15x raised to the power of 4 plus 6x squared minus 6. That is the first derivative. The second derivative, let's derive to the second derivative. F prime of x equals 15 quantity of 4x raised to the power of 3 plus 6 quantity of 2x plus 0. And the second derivative is 60x cubed plus 12x. Find the second derivative of f of x equals 3x to the power of 4 plus 2x cubed minus 8x minus 10. So we will derive f prime of x equals 3 times 4x cubed plus 2 quantity of 3x squared minus 6 times 1 plus 0. And we all know that all numbers times by 1, the answer is the number itself. So f prime of x equals 12x cubed plus 2x squared minus 6. But we need the second derivative, so we will derive it again. And again, we will derive f prime of x equals 12 times quantity of 3x squared plus 2 quantity of 2x plus 0. And the answer of the derivative is f prime of x is equals 3x squared plus 4x. And that is the second derivative. Let's find the fourth derivative of f of x equals 4x raised to the power of 3 plus 57x squared plus 38. The first derivative is f prime of x equals 12x squared plus 114x. The second derivative is f prime of x equals 24x plus 114. The third derivative is f prime of x equals 24. And the fourth derivative is f prime of x equals 0.
A few moments later.
Power rule. When a function is defined by fx equals x to the power of n, where n is any non-zero constant and x must not equal to 0. For any given n, then the derivative of fx is given by f of x equals n x to the power of n minus 1.
Example number 1. F of x equals x to the power of 5, and we will get its derivative using the power rule. First step, write down the f prime of x equals the derivative of x to the power of 5. Next, bring down the exponent of x beside the x and subtract the exponent of x by 1 and solve, and that is the final answer, which is the f prime of x is equals to 5x to the power of 4. Example number 2. F prime of x equals x to the power of 8, and we will get its derivative using the power rule. First step, write down the f prime of x equals the derivative of x to the power of 8. Next, bring down the exponent of x beside the x and subtract the exponent by 1 and solve, and that would be its final answer, which is the f prime of x equals 8x to the power of 7. Example number 3. F of x equals x to the power of 7, and we will get its derivative using the power rule. First step, write down the f prime of x equals the derivative of x to the power of 7. Next, bring down the exponent of x beside the x and subtract the exponent of x by 1 and then solve, and that would be its final answer, which is the f prime of x equals 7x to the power of 6.
A few minutes later.
The constant rule. The derivative of a constant is always 0.
So, the derivative of a constant c is equal to 0. You see this expression? It means that you differentiating c with respect to x. So, let's have the next example. If we want to differentiate 5, the derivative of 5 is equal to 0. The derivative of a negative 7 is equal to 0.
Trigonometric function. A function of an angle of an abstract quantity used in trigonometry, including the sine, cosine, tangent, and cotangent secant and cosecant, and their hyperbolic counterparts.
Given number 1, f of x is equal to sine squared x. So, anytime you have sine of x squared, what that means is quantity of sine x all being squared. So the next thing to do is to apply the chain rule on this. So it will become 2 quantity of sine x, and then the derivative of sine, which is the cosine. So now we have the final answer. F prime of x is equal to 2 quantity of sine x times cosine x. Given number 2, g of x is equals to cosecant x plus cotangent x minus cosine x. So the next thing to do is we're gonna find their derivatives. So the derivative of cosecant is negative cosecant times cotangent, and then the derivative of cotangent is negative cosecant squared, and the derivative of cosine is negative sine. So we have g prime of x is equals to negative cosecant x times cotangent x minus cosecant squared x minus the quantity of negative sine x. So if we're gonna multiply the two negatives, it will become positive. So we can put the sine x all the way in front. So we have the final answer. G prime of x is equals to sine x minus cosecant x times cotangent x minus cosecant squared x. Given number 3, h of x is equals to square root of 2 secant x all over 3. So we're gonna separate the secant x, so it will become square root of 2 over 3 times secant x. The next thing to do is to find the derivative of secant. So the derivative of secant is secant times tangent. So the final answer is h prime of x is equals to square root of 2 over 3 times the quantity of secant x times tangent x.
Chain rule. The chain rule states that the derivative of f times g of x is f prime of g times x times the g prime of x. In other words, it helps us differentiate composite functions.
The given number 1 was 1 over the quantity of x squared plus 8 cubed. By using the chain rule, the quantity of x squared plus 8 raised to the power of negative 3. Then the negative 3 will be put in front. Then you will subtract the negative 3 by 1. So it will look like negative 3 times x squared plus 8 raised to the power of negative 4. Then you will find the derivative of x squared plus 8. So it will become 2x. Then it will look like negative 3 times x squared plus 8 raised to the power of negative 4 times 2x. Then negative 3 times 2, you will multiply it and it will become negative 6x. Then the x squared plus 8 raised to the power of negative 4 will be the denominator. And the final answer was negative 6x over the quantity of x squared plus 8 raised to the power of 4. Given number 2 was the quantity of 3x squared plus 5x minus 2 raised to the power of 8. The 8 will be in the front, then you will subtract the raised to the power of 8 by 1. So it will become 8 times 3x squared plus 5x minus 2 raised to the power of 7. Then find the derivative of 3x squared plus 5x minus 2. So it is 6x plus 5. Then you will arrange it into 8 times 6x plus 5 times the quantity of 3x squared plus 5x minus 2 raised to the power of 7. And that's the final answer. Given number 3 was the square root of 5x squared plus 3x minus 1. By using the chain rule, it will become the quantity of 5x squared plus 3x minus 1 raised to the power of 1/2. The 1/2 in there will be moved in front. Then the raised to the power of 1/2 will subtracted by 1. So then find the derivative of 5x squared plus 3x minus 1. So it will look like 1/2 times the quantity of 5x squared plus 3x minus 1 raised to the power of 1/2 times the quantity of 10x plus 3. In the next process, the 10x plus 3 will be the denominator. Then,
application of higher order derivatives. One of the most common application of higher order derivatives is finding the acceleration of an object moving along a straight path. The velocity of an object moving along a straight path is given by the derivative of its position function, which means that the rate of change of the position with respect to the time is defined to be the velocity. In a similar way, we define the rate of change of the velocity with respect to the time to be the acceleration. So in short term, to find the acceleration, you need to find the velocity first before you get the acceleration rate.
Example number 1. Suppose a plane is traveling at a distance of s equals f of t, which is a function of time. T as given by s equals f of t equals 8t squared minus 4t plus 23. What is the plane's velocity? What is the plane's acceleration? So on getting our velocity and acceleration, we need to know our first derivative and second derivative. So our first derivative will be our velocity and the second derivative will be our acceleration. Our given is 8t squared minus 4t plus 23. So our first derivative will be 16t minus 4, which means our velocity is 16t minus 4. And to know our acceleration, or to get our acceleration, we need to know the derivative of our velocity. So v equals 16p minus 4. So our acceleration will be 16. Example number 2. Given s of t plus 4t cubed minus 4tt squared plus 50t plus 2 over the time interval of 0 to 10 seconds. Find the velocity and acceleration functions as functions of time. Our given is 4t cubed minus 4tt squared plus 50t plus 2. So our first derivative is 12t squared minus 8tt plus 50. So our velocity is 12t squared minus 8tt plus 50. So we will get our second derivative, which is our acceleration. So v equals 12t squared minus 8tt plus 50. Our second derivative is 24t minus 80. So our acceleration is 24t minus 80.
Optimization. Optimization is a process of finding the greatest or least value of a function for some constraint, which must be true regardless of the solution. In other words, optimization finds the most suitable value for a function within a given domain.
A few moments later.
So next is application derivatives, related rates. In differential calculus, related rate problems involve finding a rate at which a quantity to other quantities for rates of change is usually with respect to time.
So today, I will teach you the application of derivatives number 2, related rates. So example number 1 is a cylindrical glass with radius 4 cm is being filled with water from a tap at rate of 40 cubic centimeter per second. How fast is the water level in the glass rising? So we have the given of radius is equals to 4 cm and 40 cm per second is our dV over dt. So first, we will find our dV over dH because our formula is dV over dt equals dV over dH times dH over dt. So our missing is dH over dt, but first we will find our dV over dH by using the formula of B is equals to A times H, and it will become V equals pi r squared times H, and we will substitute 4 centimeter or 4 to our r because our r is equals to 4 centimeter. So it will become V equals pi times 4 squared times H, and it will be, and the answer of this is volume is equals to 16 pi h. So we have our dV over dH is equals to 16 pi. So the next process is we will find our dH over dt by using the formula of dV over dt is equals to dV over dH times dH over dt. So we will substitute dV over dt to 40 and 16 pi to dV over dH and copy dH over dt. And the next is we will transfer 16 pi to the left side and it will become 40 over 16 pi equals dH over dt, and we can reduce 40 over 16 and it will become 5 over 2 pi equals dH over dt, and by it we will come up our final answer, and our final answer is 0.8 centimeter per second equals to dH over dt.
5 minutes later.